A reminder that I have to leave here shortly before 2. I don't know exactly what time that's going to be, but it'll be when this lesson is over. So what does that mean in terms of you and attendance? Remember, the attendance is automatically taken through a program called Google Enterprise. And I think what it does is it just tracks the length of time that you're in the Google Meet. So in order to be here officially, you have to be here until 2:30. And that's fine. You're going to have some work to do after this lesson anyway. We're going to be looking at a total of, I think 6. Let me just check. Yeah, a total of 6 new identities today. These are called the Sum and Difference Identities. And we're going to be looking at a variety of different applications of the Sum and Difference Identities. I have had students in the past, even after this lesson is done, write something like sine of x plus y as sine of x plus sine of y. We've already learned in mathematics there are certain operations that you can do that and certain that you cannot. For example, if I have 2 times x plus y, we are allowed to write that as 2x plus 2y. If we have, instead of a 2, we have squaring, you are not allowed to write x squared plus y squared. This is okay, this is not. Some mathematical operations can be distributed among the pieces, but sine cannot. So just as an example, you can take your calculator and put it in degree mode for me. If I asked you to figure out what the sine of 20 degrees plus 40 degrees is, now forget about the fact that if I asked you to figure out what that is, you would just add 20 and 40 together and take the sine of 60. But if I ask you to figure out what that is, and you say, well, I'm going to take sine of 20 degrees and add sine of 40 degrees, you will discover that you do not get the same thing. So if I take the sine of 20 plus 40 degrees, I mean, I could have just typed in 60. The sine of 20 plus 40 degrees is the sine of 60, which is 0.8660 something. Okay? If you instead were to say, I'm going to try to take sine of 20 degrees and add sine of 40 degrees, you do not get that answer. So what I'm saying is, and I don't think you need to write this down, but I'm going to say it, so I want words for you to look at. The sine of a sum is not the same as the sum of the sines. You're not allowed to distribute a trigonometric function into all of the pieces inside of the argument. But strangely enough, it turns out the sine of x plus y is equal to the sine of x times the cosine of y plus the cosine of x times the sine of y. We use the letters instead of x and y in this section. We use alpha and beta. So this is the Greek letter alpha, and this is the Greek letter beta. The first 2 letters of the Greek alphabet, it's where we get our A and B from in the alphabet that we use. Now, you're going to get used to these, but let's just talk about what it means. And don't worry right now about why it's important. I've just told you that sine of alpha plus beta is the same as sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So what if we used 20 degrees plus 40 degrees? We already know what this is. This is equal to 0.866. We did that on the calculator a second ago. Well, what if I take sine of 20 degrees, cos of 40 degrees, and add cos of 20 degrees, sine of 40 degrees? I'm going to get the same thing. And I will demonstrate that to you, but you could take my word for it. So I want sine of 20 cosine of 40 plus cosine of 20 sine of 40. Remember that sine of 20 plus 40 was that 0.866, and you get the same number. So we have these identities, and you need to have your formula sheet in front of you so that you can refer to the identities. The first two that I've listed here that I'm going to highlight in yellow can be called the sum and difference identities for sine. These ones are the sum identity for cosine and the difference identity for cosine. And then we have these guys, which, you know, to be quite honest, we very rarely use, not just in this course, but even in calculus. We very rarely make use of the tangent sum and differences. Incidentally, this is not a typing mistake. The sum identity for cosine has a subtraction in it. The difference identity for cosine has an addition sign in it. Cosine is opposite. So let's take a look at a few examples. Write each expression as a single trigonometric function. So your job is to look at your formula sheet or those identities that are in front of you and come up with the identity that matches that pattern. Is there an identity that has one side of the identity that's sine of an angle, cos of a different angle, minus cos of the first times sine of the second? Yes. It's sine alpha cosine beta minus cosine alpha sine beta is equal to cosine, is equal to sine. Now you have them in front of you, so I want you to make sure that my memory is right, is equal to sine of alpha minus beta. Can I get a yes in the chat if that's correct? Okay. So I'll just let you know what the expectation is here. I expect everybody to know that 1 minus cosine squared is sine squared. If a student has to look at a formula sheet every time to figure out this, I haven't done my job. You haven't done your job. We need to know that. But nobody's going to memorize these sum and difference identities. You need to go to the formula sheet. All this means is that alpha is 42. Beta is 19, which means that this trigonometric expression is equal to sine of whatever 42 minus 19 is. And I believe, but I may need some help. My brain feels a little sluggish today. I believe it's 23. Is it 23 degrees, you guys? 42 minus 19? Okay, thank you. The next one, cosine 2 pi over 3, cosine pi over 3, minus sine 2 pi over 3, sine pi over 3. I didn't draw your attention to it, but when you look at the identities for cosine, it's cos cos minus sine sine and cos cos plus sine sine. And we don't need to worry at this level where these identities come from. So when I look at this thing, I'm seeing cosine of an angle, cosine of a different angle, minus sine of the first angle, sine of the second angle. Sometimes I just use A and B rather than alpha and beta. And this is equal to cosine of A plus B. That's what the identity is, which means that this expression is cosine of 2 pi over 3 plus 1 pi over 3, which is cosine of pi. 2 pi over 3 plus 1 pi over 3 is 2 pi plus 1 pi all over 3, which is 3 pi over 3, and the 3's cancel, so you're left with pi. And in fact, we could figure out what that is. Cosine of pi is -1, but that's not the point of this question. Any questions with number 1? Okay, I'm going to jump ahead now to the assignment, and we're going to take a look at question 1. Because I don't have examples in your notes like what you're going to do in question 1, but we can figure this out. I'm going to choose B. Sine of pi over 2 minus x would be sine of pi over 2 cosine of x minus cosine pi over 2 sine of x. The identity I'm using is this. So I want you to just pause for a second and make sure that you are aware of how I arrived at sine of pi over 2 minus x equals sine pi over 2 cos x minus cos pi over 2 sine x. All right. Sine of pi over 2 is something that you should be able to figure out. It's 1. Because on the unit circle, pi over 2 is at the top of the unit circle, and sine on the unit circle is the y coordinate. So we're left with 1 times cosine of x minus, well, what's this? Type into chat what cosine of pi over 2 is, and I hope you can come up with it without using your calculator. It's 0. It's the x coordinate at pi over 2. At pi over 2 on the unit circle, pretty crappy circle, but you get the idea. At pi over 2, the coordinates are 0, 1. So the cosine is 0. You're left with 0 times sine of x, which means it's cos of x. 1 times cos of x minus nothing is cos of x. This is a very useful way to simplify expressions. A lot of the time in applied mathematics, which is what calculus is, you end up with an expression like this, but it's much better to use cosine of the angle instead because it's simpler. Okay, let's get back to the examples. 2, determine the exact value of each expression. So there are 2 main types of examples, number 2 and number 3, that you need to know how to do. Now, if you were to look at where 7 pi over 12 is on the unit circle, let's just do a calculation here. Pi is 180 degrees. So can you work out for me, please, what 7 multiplied by 180 divided by 12 is? I think it might be 105. 105. Okay. So what we're asked to do here is find the cosine of 105 degrees. And in fact, regardless of my explanation, we should think in degrees here anyway. It's going to be easier. So I'm going to look at my unit circle at where 105 degrees is. 90 degrees is at the top. Let me resize some things here. Way too big. 90 degrees is at the top. This is 90 degrees. This is 120 degrees. We want 105, right? 105 degrees is between there. So you're asked for, in this question, the cosine of 105 degrees. If I said to you, what is the cosine of 90 degrees? You know that. You know the exact value. If I say what is the cosine of 120 degrees, you know that. If I say what is the cosine of 135 degrees, you know that. Because 90, 120, 135, 150, 180, those are all on the unit circle. But, darn it, 105 degrees is not on the unit circle. So what we're going to be doing is using our knowledge of points that are on the unit circle. I'm going to back up. I just said 105 degrees is not on the unit circle. That's a blatant lie. 105 degrees is on the unit circle. We just don't know the coordinates of it. So what we're going to do is rewrite 105 degrees as the sum of two angles that are both known angles on the unit circle. So I want you to think about that for a second. What two angles could we add together to give 105 where each of them are those points that we're familiar with? And if you get the two angles, you can type it into chat while everybody's thinking. Sure. And you know what? All of these questions, all of these ones where you're asked to find a trig ratio of an exact value, but the angle is a weird angle, one of the angles will be 45. So I'll go cos 60 plus 45 degrees. How is that helpful? Well, we have an identity that says cosine of 60 plus 45 will be equal to cosine of 60, cosine of 45, minus sine of 60, sine of 45. I don't want you to be complacent here and just write it down without thinking. Look at your formula sheet or an identity resource and look at the identity for cosine of an angle plus an angle. You will discover that it's cos of the first, cos of the second, minus sine of the first, sine of the second. Any questions to that point? Okay, now I hope if we have all done our job properly and well, I hope that everybody knows cosine of 60. I'll show you the unit circle in a second, but by the way, cosine of 60 is a half, and I would hope that many of you would just know that it's a half. When you take a look at 60 degrees on the unit circle that's up here, the x-coordinate is a half, so the cosine is a half. Multiplied by, I hope that everybody knows cos of 45 is root 2 over 2. Because 45 degrees is this point where you have equal x's and y's, and the coordinates, I'll show it to you now. The coordinates at pi over 4, which is 45 degrees, are root 2 over 2, root 2 over 2. So at 60 degrees, the cosine of 60 is 1/2. At 45, the cosine of 45 is root 2 over 2. Then we have minus, and we're going to do the same thing with sine. Minus the sine of 60 is root 3 over 2, and the sine of 45 is root 2 over 2. And I suppose for this lesson you could have your unit circle in front of you, but you should be able to figure that out. You know, you should know, it's going to get a little small for me to write here, that the coordinates of this point are 1/2 comma root 3 over 2, which means the sine of 60 is root 3 over 2. It's the y coordinate. I don't know if I should risk, I don't think it'll fit. This is root 2 over 2, comma, it's just going to fit really small, root 2 over 2. So the y coordinate there, which is the sine, is root 2 over 2. Now we simplify this. We multiply across the top. 1 times root 2 is root 2. We multiply across the bottom. Strangely enough, a lot of people forget to multiply the 2 by the 2 on the bottom. Then we have minus root 3 times root 2, which is root 6, over 4. We can put this together with a common denominator, and you get root 2 minus root 6 over 4. Okay, let's just check something out. I'm going to choose to work in degrees here. We could do the same thing in radians, but it's tougher to think about and explain. I'm going to take the cosine of 105 degrees, and I get this wacky number. I'm going to take the square root of 2 and subtract the square root of 6, and then divide that number by 4, and I get the same wacky number. This is an academic algebraic course preparing you for calculus and post-secondary. A typical exam question might be cosine of 7 pi over 12 equals root A minus root B over C. What are the values of A, B, and C? Well, it's 2, 6, and 4. And I'll tell you, there really is no way to cheat with your calculator here and figure out what those numbers are. Although I will tell you something. I'll tell it to you once, and if you remember it, it might help. A lot of the time, the numbers are 2s, 6s, and 4s. Okay? A lot of the time. Let's look at the next one. What is the tan of 165? So we're going to break this down into two angles that either add or subtract to give 165. Well, if it ends in a 5, one of the numbers has to be 140. One of the numbers has to be 45. And the other one, I guess, is 120 degrees. And now we have to look at the sum identity for tangent. And you know what? I couldn't tell you what it is. I would have no clue what it is because I haven't used it in a couple of months, and it's really not that important. We can look it up. There it is, right here. It's tan plus tan over 1 minus tan times tan. So this will be tan of 45 plus tan of 120 over 1 minus tan of 45 multiplied by tan of 120. Because tangent is y over x on the unit circle, this requires a little more care in figuring these out. So let's deal with the 45 degrees first. At 45 degrees, the coordinates are root 2 over 2 comma root 2 over 2. Well, that means that tangent of the angle at 45 degrees is y over x, which will be root 2 over 2 over root 2 over 2. Well, it's 1. The tangent of 45 degrees is 1. So we can put 1 every place we see tan 45 degrees. Now I still need to put in what tan of 120 is. So I'm going to sketch a rotation arm at 120, and we're going to calculate the tangent of 120. 120 degrees is the 30-degree arc just past 90 degrees. And the coordinates there are negative 1/2, comma, root 3 over 2. You can see that the x-coordinate is clearly 1/2. Well, it's negative 1/2. The y-coordinate must be root 3 over 2. So tangent of 120 would be root 3 over 2 over negative 1 over 2. Pretty simple thing to solve or simplify. Multiply top and bottom by 2. The 2's cancel, the 2's cancel. You're left with root 3 over negative 1, which is negative root 3, which goes in which goes in for tan of 120. I had written a second to go plus here on the bottom. I should have written minus. So tan of 120 happens to be equal to 1 minus root 3 over 1 plus root 3. Any questions with any of the steps in the second example in number 2? This type of question, finding an exact value of a trigonometric ratio for an angle that ends in 5 degrees, is something you need to know how to do. All right, the last example is number 3, and we're going to spend a lot of time with 3a here. Well, I don't know what a lot is, probably about 10 minutes. But once we do 3a, b and c are really, really simple to do. The first thing I want everybody to do is to rewrite this question, and we're going to think of it as being cosine of angle A equals 5 over 13, and tangent of angle B equals 4 over 3. Everything else in the question is still the same, but I want to not use x and y when we do our work. That means what you were asked to find is sine of A plus B. And I suspect that many of you understand why I'm doing this. The reason is we're going to be relying on trigonometric ratios being defined in terms of x, y, and r, but the x and y in the original question are angles, not coordinates. By the way, this x here is angle A. This y here is angle B. And every time I teach this, somebody ends up asking me at some point, well, why don't you just make the example like that? And the answer is because on a diploma exam, it's not necessarily like that. They like to mess with you on diploma exams by using x's and y's, where x's and y's are angles. But in order to find the answer to the question, you have to use x's and y's as coordinates, which are different x's and y's. We've talked about that before. So how are we going to find sine of A plus B? Well, sine of A plus B is sine of A, cosine of B, plus cosine of A, sine of B. So first of all, I guess any questions about, better do this. Any questions to begin with about the fact that we're changing the question to have angles A and B rather than x and y? Does that, any comments or questions about that? We've done this before, but only where we've had an x. Now we have an x and a y. Okay. Does anybody have any questions as to why I am allowed to write this? Or maybe I'll ask you, can somebody type in the chat why I'm allowed to write what I put in that bluish box? Is my mic on? That's a joke, by the way. So I'm asking, why am I allowed to write sine of A plus B equals sine A cos B plus cos A sine B? Yeah, it's an identity. And I guess I get why you might have been thinking, well, what the heck is he asking? You're allowed to write it because it's true. I guess what I'm getting at is it's the sum identity for sine. Okay, so how do we find sine of A? Well, what we do is we use y over r. There's very little in high school math that you learn that you don't use later on, which is why it's, if you do not do so well on one unit or one course, it's harder to move forward, unlike a lot of other classes. You got to remember a lot of stuff here. Cosine is x over r, but here's the kicker, or as your English teacher would say, here's the rub. The r when we calculate sine of A is different than the r when we calculate cos of B, because angle A will have its own x, its own y, and its own r, and angle B will have its own x, its own y, and its own r. We're going to come back to that in just a second. How am I going to calculate cosine of A? Well, cosine of A will be x over r. But the x and r I use to calculate cosine of A will be different than the x and r I use to calculate cosine of B, because they're different angles. And sine of B, sine is y over r. So now let's start figuring out what x, y, and r are equal to. Look at what we've set up here. I can't point, so I'll do some more highlighting. I'll use the very offensive pink color, offensive to your brain. Looking at that, that's a reference in terms of angle A. I didn't mean to use the word reference. That is a description relating to angle A, and it's cosine, which means that the 5 over 13 is x over r. That 5 over 13 has to be x over r, which means for angle A, x is 5 and r is 13. If I look now at the statement tangent equals 4 over 3, that's talking about angle B, and tangent is y over r. Sorry, tangent is y over x. So I better write this down. Over here I'm saying cosine of angle A is x over r, so that's why I put 5 over 13 as being the equivalent of x over r. X is 5, r is 13. Over here, I'm saying tangent of B is y over x. I hope you understand how confusing that would be if I didn't change the x to A and y to B. So, I'm going to put 4 for y in angle B and 3 for x in angle B. Does anybody have any issues or problems with what I've written so far? I'm asking you to use your head and make sure that everything I've written down is correct. Let me help you out. Something is written down that's wrong. And I'm going to give you a minute or so to see if you can figure it out. And if you're looking only at your screen, then you are going to miss it. So I will extend my screen to show the whole question. And I'm going to sit down in my comfy chair right now, recline, and wait for somebody to see if you can figure it out. YB is negative. Why is that, Aiden? So what you're saying is, for angle B, y should be negative 4. And that is correct. It's in quadrant 3. And in fact, now Katya is pointing out x, so is x, negative as well. So because, it may be easy to miss that, but it says this is not partially on the fish. This is important information. Angle B is in quadrant 3. And in quadrant 3, I don't want to fill up the board too much with much more clutter, but in quadrant 3, down here, x and y are both negative. Okay, so we've got that fixed. Now what we're going to do is calculate y. Let me get back to a reasonable view. Now what we are going to do is calculate y for angle A, because we need to know that, and r for angle B, because we need to know that. Because if you look at all of this, this is the answer to the question. We need to be able to put numbers in for all those x's, y's, and r's. This is a Pythagorean Theorem thing. Getting lots of practice today writing small. So for this, it would be 5 squared plus y squared equals 13 squared. For this, it would be negative 3 quantity squared plus negative 4 quantity squared equals r squared. So we can calculate r and we can calculate y. And many of you probably know whenever you have 3 and 4 on a Pythagorean triangle, the hypotenuse is 5, so r is 5 here. And some of you might know that another perfect Pythagorean triple is 5, 12, 13. So can you confirm that when you take 13 squared and subtract 5 squared and then take the square root, you get 12? Okay. Is everybody fine with y being 12? Good. You should not all be fine with y being 12 because it says that angle A is in quadrant 4. My God, what a lot to keep track of here, you guys. You got 2 different sets of x, y's, and r's. You have to look at the quadrants to determine what's positive and what's negative. It's a lot of work here. It's not, you know what, it's not a lot of difficult work, it's just a lot of work. You need to be organized. So if it's in quadrant 4, that's here, x is positive, which it is, and y is negative. So when you figure out what y is, you end up having plus or minus 12, and the answer is negative 12. Now we put everything in. Just want to move this over a little bit if I can. All right, so what is y over r for angle A? Well, it's negative 12 over 13. What is x over r for angle B? Well, it's negative 3 over 5 plus x over r for angle A is 5 over 13 multiplied by y over r for angle B. Sorry, fell asleep there for a second. Negative 4 over 5. And I'm just going to double check all those. Can you double check them as well and let me know if you're satisfied with that? I think it's fine. But look at, I know sometimes I'm all over the place on the board, but look at how I've tried to keep things organized here. And I know this from experience. The first couple times I taught this, I was bouncing all over the place. You have to, for these questions, be really careful and deliberate and organized in your thought, otherwise you'll get wrong answers. So now it's just a matter of simplifying this. This works out to 36 over 65. I know you want to use your calculator, but I just multiplied across the top, multiplied across the bottom. Plus, you get negative 20 over 65, which means it's 36 minus 20 over 65, or 16/65. This is our answer. Any questions with A? Okay, so I mentioned that we would spend about 10 minutes on A. That's not bad, it was 7 minutes, but look how easy question B and C are. What is the cosine of A minus B? Remember, we changed the x's and y's. Well, it's cosine of A, cosine of B, minus sine, nope, plus sine of A, sine of B. I'm going to write something else down here just to help keep me organized. This is x over r. This is x over r. This is y over r. And so is this a y over r. Now you have, I just want to check my handout. Yeah, all of your questions are on the same page, so you can see what x, y, and r are for angle A and angle B. I'm going to go by memory. Please let me know if for angle A, x is 5 and r is 13. Is that correct? Okay. For cosine of B, x is negative 3 over r, which is 5. Is that correct? Okay. So I got it sorted out in my head. That must mean we have negative 12 over 13 for y over r for angle A. And is that right? Okay. And then that leaves negative 4 over 5 for y over r for angle B. Is that one correct? So it looks good. All right, so now we simplify this. We get negative 15 over 65 plus 48 over 65. You can put these numbers together. It works out to 33 over 65. Can you confirm that when you crunch these numbers, and you can do it on your calculator, that you get 33/65? Marissa's got it. Welcome back, Aaron. Aiden's got it. Sarah's got it. Okay. Patrick's got it. Okay, so that's the answer. One last one. And again, I don't remember these, although I think I'm going to try to remember this one because we already used this today. A plus B equals 10A plus 10B over 1 minus 10A 10B. Is that correct? Okay, good. So, you know, I could really put everything in here, but all of these are y over x, right? This is a y over x. 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 So I'm going to just, to make my life a little easier on the brain, tan of A is y over x. Is that correct for y over x for angle A, negative 12 over 5? Okay, so what I'm doing, I hope that you're all paying attention to this, but what I'm doing is I'm going back to this list here that you see above this line. That's what I keep going back to in my head. All of those different x, y's, and r's. And that means that tangent of B is 4/3, and that was in fact given in the question. So all we're going to do is put those things in. Tangent of A is negative 12/5 plus tangent of B is 4/3 over 1 minus negative 12/5 times 4/3. Listen, don't worry about mini denominators here. When they're numbers, figure out what the top is on your calculator, figure out what the bottom is on your calculator, and go from there. There's a way to simplify this, but you know, at some point we have to kind of get with the 21st century. We've got technology to calculate these numbers. We don't need to do it on paper. It's not 1975. So I'm going to take tan A plus tan B, that's negative 12 over 5 plus 4 over 3. I turn the calculator on first. Negative 12 over 5 plus 4 over 3. I'm going to change it to a fraction just so I can write it down. It's negative 16/15. I know in the time I explain this, you probably already have an answer, but I want to double check that negative 36 and 20 is negative 16/15. That's correct. On the bottom, you should get 63/15, I think, but I better check that. I might be off a little bit. 1 minus negative 12 over 5 times 4 over 3. (21/5). Oh, I said 63/15. 63/15 reduces to 21 over 5. So we have over 21 over 5. If you put this into your calculator now, make sure you put brackets around the top and the bottom. Work out what the answer is. I will show you what I would do because I went to school in the 1970s. Oh man, that's not a happy thought. I would multiply top and bottom by 15 so that these cancel. This cancels and leaves you with a 3. So I'm left with negative 16 over 3 times 21, which is 63. Do you get the same answer on your calculator? Okay. By the way, it wasn't like I was in high school in the 70s, okay? Don't get the wrong idea. It was in elementary and junior high. Attached problems, I've highlighted them here, which tells me that I think these are the ones I want you to do. Certainly if you wanted to do question 3 and 7, and if there's a 13 and a 14, you could, and I would be happy to go over them with you at some point. But that's it for the lesson. Give me a too fast, too slow, just right check here. Okay, so you know, I have a feeling even if I didn't have to leave for an appointment right away, I have a feeling I'm not sure I'd be happy with continuing on to the next lesson. And I think what we're going to do tomorrow is do one lesson and maybe just get some more practice in working with the identities from yesterday. There's a whole whack of problems in your textbook dealing with yesterday's lesson. So I'm still going to be here for about 15 minutes. Thanks for the feedback. And then I'm going to leave. I am going to keep my Google Meet open here because then it continues to record who's here because the teacher is here. But I will not be around starting at about 2 o'clock. I'll let you know when I'm leaving though. So if you do have a question in the next 15 minutes, let me know.